All right, so let's go ahead and practice a projectile motion problem. We have a baseball player throwing a ball 13 meters per second horizontally, and we want to know how far from the base does it go. So we want to know S, how far from the base does it go. Now, we talked about in class how in the x direction, the velocity all the way down stays the same, 13 meters per second. And because it stays the same, there's only one equation that works in the x. You have V equals S over T, delta S, the displacement in time. And now this is not on your equation sheet, but you should remember that for Vx, that's the only equation that works. And so we know the x velocity. We want to know how far it goes, and we need to know time. Another thing that we talked about is how, if you throw a ball perfectly straight out horizontally and you drop one, they're going to take the same time to fall. And we spent a lot of time with that as well. So the key here is Vy initial is 0. We're starting with no y velocity, and so we can figure out the time and therefore figure out how far it goes. So go ahead and pause the clip and do this one, and when you're ready to check, you can hit play to continue. All right, so we should get 4.52 seconds as the time of free fall and a displacement in the x of 58.73 meters. And I emphasized as well the importance of using, use the variables from the equation sheet, and that'll be good practice for you here. One of the other things that we talked about today that is critical is the time of flight for projectile and looking at projectile motions at upward angles. So we know that projectiles spend half the time going up, half the time going down. We also looked at how, the x velocity stays the same the whole way. So at the very top, right, it's going to be Vy is 0 at the top. You start out with some y velocity and they get smaller, 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 and then 0 at the top. And we can take that to our advantage because, the equation V equals U, let's see, final velocity equals initial velocity plus acceleration times time. The velocity at the top is 0, and therefore V final is 0 at the top. We know the initial velocity in the y, and we can find time halfway. So let's go ahead and set that up here with the soccer ball that's being kicked, an angle of 25 meters per second, or 25 meters per second, an angle of 25 degrees, 9.5 meters per second velocity at the angle of 25 degrees. Now remember, the very first thing that you got to do is break it up into what is Vx and what is Vy, right? And you can use your trig, it's 25 degrees. And Vx is going to stay the same the whole way. And so just like with the last problem there, the only equation that works for the x is displacement over time. And therefore we need to find time, and we can find time halfway because we know at the top the velocity in the y is 0. So go ahead and pause the clip and give this a try, and when you're ready to check, you can hit play to continue. All right, so 8.61 meters per second in the x, in the y 4.01 meters, and we've got our setup there for the y. Time halfway is 0.4097, multiply by 2 to get time the full way, and we can figure out how far it goes. So it'll go 7.05 meters is how far it'll go. All right, so for this one, will this ball make it over a 40-meter wall, which is halfway? So go ahead and pause the clip and give this a try, and when you're ready to check, you can hit play to continue. Okay, so we know the velocity in the x, we know the velocity in the y, and we're looking for the height halfway. So therefore, we can find the time halfway by using, we know the velocity at the top is 0, we know the initial velocity in the y, time halfway is this. So that's what we want. We want the time halfway, and then we can use, the s equals ut plus 1/2 at squared, and calculate the height at the midway point. Or you can use this equation. We know the velocity halfway is 0. We know the initial y velocity. We want to know how high it goes. It's going to go 42.7 meters halfway. I'll go ahead and show you the work for this one. All right, so let's go ahead and try this one now. At 37 meters, how high is the projectile? So at 37 meters, in terms of length, how high will it be? And so not halfway, but at 37 meters. So yeah, go ahead and pause the clip and give this a try. And when you're ready to check, you can hit play to continue. All right, so the key with this one is looking for the height, right? And we know the initial height is 0, the final height is what we're looking for. We need to know where it's going to be at 37 meters, or how much time it's going to take. So 37 meters is x, we know Vx. So the time period, 1.073, that's the time at which it will be at 37 meters, and then therefore we can figure out how high it'll be at that spot, and it will be 25.395 meters at that spot. All right, so let's go ahead and try this one here. We've got a ball that's hit at 19 meters per second at 30 degrees, and the question is, will it clear the net? And it's 11.98 meters away, and the height of the net is 1 meter. So yeah, go ahead and pause the clip and give this a try. And I'll give you a hint here. It's your X problem that's going to have to help you here to figure out what's going on in the Y. So yeah, go ahead and pause the clip and give this a try. And when you're ready to check, you can hit play to continue. Okay. So yeah, this is another way to state it. In other words, what is the height at 11.98 meters? We get our Vx and Vy. And so for our X problem, the question is, what time period is it going to be at the net? It's going to be at the net at 0.723 seconds, because we know the X velocity stays the same the whole way, and that's how far the ball is away, so that's how much time it's going to take to get there. And therefore, when we calculate this out, we can look at, okay, what's the height going to be there for the Y problem? And the initial height is 0.3, and we can find the final height, and the final height would be 4.6. And therefore it will clear it by 3.6 meters. Now, if you use the equations on the equation sheet, S equals UT plus 1/2 AT squared, you'll get an S of 4.3. Now, you're starting at 0.3, so you'd have to add that to the 4.3 to get 4.6, and that's how high it'll be. So it's going to clear the net by a pretty long amount there.